day 2 or lesson 2 of actually talking about rational exponents and day 2 of solving, which is going to take a little bit farther. We're going to go farther with what we're doing. First thing it says is rewrite in radical form. Keep in mind that fraction has the power number on top and the root number on the bottom. So I'm going to have 7 to the first power, and I'm going to take the second root. Now most people don't say second root, they say square root. So that's the same thing as just square root of 7, simple and easy. But if I put the 1 and put the 2 that are understood to be there, that's what it would look like. So you can either write it this way or this way, same thing. Okay, 2 to the what power? 2 to the 5th power, 2 to the 3rd power? Power numbers on top, roots on the bottom. So it's 2 to the 5th, and I'm taking the what? 3rd root. You must show the 3 in the corner. That's the way that it says 3rd root. That is the only way to write the answer for number 2. Okay, you cannot leave out the 3 because if you do, it's implied to be a 2. Okay, it's the only thing to keep in mind. Okay, number 3. What do you first thing you notice? Does anybody notice? Does it jump out at you? Hey, that's a negative exponent. What do I need to do to make my negative exponent become a positive exponent? Move it. So I'm going to have to move it first. Okay, so if I take the 6 downstairs, I'm going to take its negative exponent 3/2 with me, but what happens to the negative 3/2? It becomes positive 3/2. Okay, so basically I have 1 over, so that negative exponent just basically moves it from the top of a fraction to the bottom of a fraction. Now, is it 6 to the 3rd power or 6 to the 2nd power? 6 to the 3rd power, and we're taking what? The 2nd root or the square root, and that's my final answer. The only thing what really happened is that negative exponent moved my answer to the bottom of a fraction instead of the top of a fraction. Number 4, notice that I have parentheses. Okay, that means both parts, both the 5 and the x are closest to the 3/4, that's with parentheses. So I have to keep 5x in parentheses. Am I raising 5x to the 3rd power or to the 4th power? To the 3rd power. And then I'm going to take what root of that? I'm going to take the 4th root. So I must show a 4 there. Now there is an alternate way of showing your powers. You can say, let's take the 4th root of 5x and put parentheses on the outside with a big 3rd around the whole thing. So I can either put my power inside the radical, or I can put my power outside the radical, and it's still just as good. So that actually works either way you want to write it. Power can be on the outside, or power can be on the inside. Everybody okay on 1, 2, 3, 4? Again, trying to emphasize power over root, because this is the first time to my knowledge that you've had to work with fractions exponents. Okay, number 5. Now, I'd like us to try the next 4 or 5 problems here without a calculator. But if you have your calculator right there handy, we're going to confirm our answers with a calculator. Okay? Here we go. 25 to the 1/2 power. That's 25 to the what? 25 to the 1st power. And I'm taking the what? 2nd root, which is square root. What's square root of 25? 5. Okay? That's what I want us to do. A lot of these, every single one of these right here, I can do without a calculator. Okay? I'd like us to try them with a calculator, but I will be honest with you. I've told you from the beginning, you will never have to not use a calculator on the final exam. All right. What's being raised to the 1/2 power? 36 and into the 8th, both, right? So do y'all remember how we said a while ago, what do I do to inside exponents and outside exponents? I multiply those. So that's going to be 36 is going to be raised to the what? 1/2 power. Whoops, 36 to the 1/2 power. What about n to the 8th? What's 8 times 1/2 power? How do you multiply 8 times 1/2? It's like 8 over 1. So that'd be 8 over what? 2. What's 8 over 2? 4. So that's going to end up giving me n to the 4th. Does everybody understand how we did that? We multiplied inside exponent times outside exponent. That's why I want to review exponent rules with you. I'll probably do that for the next few days so that you can get a chance to practice. What's 36 to the 1/2 power? That's 36 to the first power, taking the what? Second root. So that's 6n to the 4th. Final answer. Now I can do this in my calculator. I can do the 36 to the 1/2. I can't do the n to the 4th with my calculator. What about 81 to the 3rd power raised, taking the what? 4th root. Now in this problem, let me ask you a question. I'm taking the what? 4th root. Now I don't want to pick our calculators up just yet, but then I want you to pick your calculators up in just a minute. So give me about 30 seconds. Did I say a while ago that it didn't matter if the power was on the outside or on the inside? All right, in this case it doesn't. I do know that if I put 81 to the 3rd power and then I take the 4th root, that's 81 times 81 times 81 3 times. That is going to be a huge number. Agree? So if I'm trying not to use my calculator at the beginning, I probably won't do it that way because that's just too big for me. But I think I might can do this one. Let's ignore this. What number times itself 4 times is 81? 4 times 4 times 4. Let's just break down 81. How would you break down two numbers that give me 81? It's not 8 and 8. It's 9 times 9. And then what? 3 times 3. Miss Abby had it just a minute ago. She figured out that it's what? 3 times 3 times 3 times 3, 4 times. Does that make sense? And that would give you 81. So the answer to the inside of this would be what? The answer that's on the inside, 3, is the 4th root of 81. What am I going to do to the 3 now? Well, I still need to raise it to the outside power of 3. What's 3 to the 3rd? 27. Does everybody kind of follow the logic? I know you don't have to do it in your head, but it's good to understand how we could do it in our head. Now, grab your calculators. Type in the original problem, 81 to the 3/4 power. Let's grab our calculators. Okay. Let's see. I think I can just type. Let's see. 81. I'm just going to try it because I've not done it with this one. 81. How do I raise it up? There we go. To the 3 divided by 4. And what I love about it is what? If I hit the divide bar, it makes it a vertical fraction for me without me having to do anything. And what's my answer over here? 27. Did y'all get that? Okay. Now, Desmos is available, but if you don't have your Chromebook with you and you want to grab your calculator, you can do the same thing with your calculator. So I can type in 81 raised up to, and you guys have an up box, to the 3 divided by 4 power. Oh, I have to put parentheses because I don't have a box. Parentheses 3 divided by 4 power, and I also get what? 27. So this is an old calculator, and you know that my 83 is older. Okay, hopefully so far so good. We've confirmed the answer with our calculators. Okay, next number 8. Let's try it without our calculator first. What's the first thing you notice about 27 to the negative 2/3 power? I need to move it to the bottom. So I'm going to move 27 to the negative 2/3 down here, and it's going to become 27 to the positive 2/3. Okay? So my answer is it's going to end up being on the bottom instead of the top. That's okay. 1 over. Now, I'm going to take 27 to the what power? 2nd power, but I'm going to take the 3rd root. So I'm going to take the 3rd root first, and I'm going to raise the answer to the what? 2nd power. That is easier mathematically for me to do. Now, I'm asking myself on the bottom, what number times itself 3 times is 27? That's 3. Does everybody see it's 3? So I'm going to get, so this inside part's just going to become a big 3. Now 3 has to be raised to the 2nd power, which would be 1 over 9. Okay, let's confirm with our calculators. So I'm going to type in exactly what the problem was. 27 raised up to, and again, I have an old calculator, negative 2 divided by 3. And I'm getting, I got 0.11111111. Got to get it right. Got to do that math fraction key. Math fraction, enter, enter. And it does confirm that my answer really is what? 1/9. So I want you to try some without the calculator, and then I want you to do some with the calculator. And today you have practice on doing that. Last one, number 9. Okay, and then we're actually going to start solving. Number 9. What would I do first on number 9? Everything on the inside gets a piece of the outside exponent, so I'm going to what? Multiply the inside exponent times the outside exponent. So it's going to be negative 8, and I'm going to keep parentheses around the negative, so the negative goes with the 8, to the what? 1/3 power. That's x to the 2 times 1/3. How do I do 2 times 1/3? What do I get? Ryan, what do I get when I say 1/3 times 2? 2/3 power. Y to the 6 times 1/3. 6 over 1 times 1/3. What would I get if I do 6 to the 1, 6 over 1 times the 1/3? Y to the second. Does everybody agree with y to the second? Okay. The only thing I haven't done yet is my negative 8. That's actually negative 8 to the first power, taking the 3rd root. Now here's what I have to ask myself. What number times itself 3 times is not just 8, but negative 8? Same number 3 times. 2. No, 2 times 2 times 2 would be positive 8. Negative 2. What's negative 2 times negative 2 times another negative 2? Well, negative times negative would be positive 4. But what's positive 4 times another negative 2? Negative 8. So that actually gives me a negative 2 when I simplify the square root, or excuse me, the 3rd root. So that answer would be negative 3, x to the 2/3, y to the positive 2. That's my final answer. Oh, sorry, you're right, negative 2. It was just a brain lapse there for a sec. All right, let's pick back up with number 8. This time we're not simplifying, we're just rewriting. They've given me the radical. I have to write the fraction exponent. Number 8. What number is understood to be the root of my 10?
2.
That's the second root or the square root. So that would actually be 10 to the what? 5 over 2 or 2 over 5? 5 over 2. Michael, what about number 9? What fraction exponent would I be able to rewrite it with? That's 2 to the what? 4 over 3 or 3 over 4? 3 over 4. Power goes on top, root on the bottom. That is correct. What about number 10? Is the 7 or the y or both being raised to that power? Well, they're both underneath the bar, right? So they're both included. So it's probably going to have to be 7 and y with parentheses, because you have to show that they're both involved. Now, is it going to be 5 over 3 or 3 over 5? 5 over 3. 5th power over 3rd root. 5th is your power. 3 is your root. Power over root. Okay. Last one. M to the what? This is an easier one. I don't have 2 numbers, or do I? I really have a 1 over 5. So today you're going to get a chance to practice this. We introduced it yesterday for the first time. Today we're actually following up with that for a second opportunity to see it, to practice a few, and then I'm going to let you do some in a few minutes on your own. Okay. Let's start the second part of solving. Second part of solving. Whew, be a bad day. Could have been a bad day. All right. Some of these are very similar to yesterday. What do I need to do first to solve for x? Okay. Just like I did yesterday. These are just like yesterday's. I want to get the radical term by itself. This is the radical term. So I have to get rid of 5, so I'm going to subtract 5 from both sides. Square root x minus 3 is equal to 10 minus 5 is 5. Now, how do I solve and get the x out from underneath the square root? Square both sides. Raise it to the second power. If you raise one side to the second power, you have to raise both sides to the second power. The square root and the square cancel, and I get what? X minus 3. What's 5 to the second power? 25. So final step for x is add 3. So x is equal to 28. If I put 28 up here, 28 minus 3 is 25. What's the square root of 25? 5. 5 plus 5 would be 10, so it does check. What would I do in 13? This time I have a square root on both sides. So I've done everything I can to get the radical. It's already by itself. So I'm going to go straight to the step where it says what? Square both sides. But you have to remember to square every part of both sides. So I'm going to square the 5 that's on the outside. I'm going to square the square root, and I'm going to square the square root on the other side. Every single thing in the equation got squared. Everybody good with that? What's 5 squared on the outside? 25. Okay, what happens to squaring a square root? Square root and square cancel, and what comes out? 2x. So guys, you have to multiply times 2x, or you can put 2x in parentheses, because that's 5 times that. Square root and the square cancels, what do you get? 10x plus 80. Once you finish and solve it, tell me what you get. You solved it. To finish this, the answer turns out to be, and I've seen several of your papers, y'all get what? 2. X should equal 2. 50 times 2x is, or excuse me, 25 times 2x is 50x. It's equal to 10x plus 80. I'm going to subtract 10 from both sides because I want to take all my x's to the same side. 40x is equal to 80. Now I have to divide as my final step. What do I divide by? 40. Divide by the number in front of x, which is 40. And so I did get x is equal to 2. And 2 does work if you check it. Take my word for it. Okay. Yesterday we did introduce the idea that sometimes you may have an extra answer. What do we call that extra answer? Well, sometimes we may have no solution, but sometimes you get an extra answer. It's called extraneous. It's got the little word extra. Can y'all say extraneous for me? Extraneous. Sometimes you will have extraneous solutions introduced because that strategy of squaring both sides, sometimes it allows answers to be found that are not necessarily going to work. All right, we're going to see that happen today. Number 14. What would I do first in 14?
We gotta subtract the 7.
Subtract the 7. Subtract the 7. Square root of 3x plus 6 is equal to negative 6. No solution. Ding, 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 ding. Why did she know it was no solution just like that? We never have our calculator, ever, 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 ever. Our calculator can take the square root of any number, and it will never spit out a negative answer. What's the square root of 36? 6, right? What's the square root of 49? 7. It never says negative 7. It never says negative 6. So you can't take the square root and equal a negative. So that's where it's no solution. If you recognize it right there, yeah. Did we try yesterday where you work it out and you may get an answer? But how would you catch it then? If you plug it back in and you check it, the answer does not work. Okay. Well, and they need to catch it here. Otherwise, no solution, you're going to miss it. What about 15? Whoa, we've never done one like 15. Or have we? Okay. We've done this a few times. What's 36 to the 1/2 power? I'm just doing something, give an example. That's 36 to the first power, taking the what? Second root. So that's basically 6. What's 49 to the 1/2 power? Well, okay. So are you telling me that 1/2 is really square root?
Yeah.
Ah. So really right here, I could rewrite this as what? 3x plus 1 under the radical sign equal to 7, because 1/2 is the same thing as that square root. So if you jot that down on your paper, 1/2 power is the same as square root. So recognizing that gives it's half the battle. So now, have we actually worked problems like this before? So make that adjustment. 1/2 power is really square root. And that's part of what I really need you to understand. 1/3 power is really cube root. Okay? All right. So how would I solve? Square both sides. 3x plus 1 comes out. Because a square root and a square cancel, equal to what? 49. 7 times 7 is 49. Subtract 1 from both sides. 3 times x is equal to 49 minus 1. 48. Now what? Divide by 3. So x is equal to 16. If you did put 16 back, in here, 3 times 16 plus 1 under the square root. 3 times 16 is 48. 48 plus 1 is 49. That's all under what? Square root, and that would be 7, and that says equal 7. So does that check? Yes. The only time they don't check out usually is when you have that equal a negative. Okay. Ooh. How would I start 16? That's really square. Now, what's under the square root? Is 4 and x both under there, or just the x? Both. Very good. Because they're both. You can put the parentheses around it, but if it's all under the bar, you're okay, because it's just to the first power. Normally, I would use parentheses. So square root with 4 and x under there, because they're both included. The exponent goes with the first thing it touches. So it goes to the parentheses, so everything in parentheses goes under there. So I would simply do what? I'm going to get a fraction this time. And it's not going to work out, but I'm going to leave my answer as a fraction. So square root and square, the square root and the square cancel, and I get what? 4x out. What's 3 squared? 9. Divide out the 4, and I get a fraction because it does not simplify equally, and I'm fine with leaving it as a fraction. If you did type it in your calculator, I think you'd get, is it 2.25? You can change it if you want to. I'm fine with 9/4. Now, 17 looks almost like 16.
It's just the x. The x has the.
Ah, she's already picked up on that. Did y'all hear what she said? Only x has the exponent. So 4 stays on the outside, just a normal 4. The square root only goes over the x. Everybody see that? So the parenthesis, or excuse me, the exponent goes to the closest thing it touches, so it only goes to the x, equals 3. Now I'm supposed to get my square root by itself first, so I really need to get rid of the 4. How do I get rid of the 4? You can't minus it because there's no plus. So you can divide it. So I'm going to get the square root of x is equal to 3 over 4. My answer is going to be a fraction again. So I'm going to square both sides. The square of a square root gives me my x out. So now I just got x. But how do you square a fraction? Do you square the top number? Do you square the bottom number? Or do you square both? You square both. What's 3 squared? 9. And 4 squared is 16. So my answer was similar to the last answer, but not exactly the same as the last answer. Did y'all see the subtle difference between which one the exponent touches and which one it doesn't? Okay. So today was about pushing it a little farther. So we just got a few more problems to go, right? All right. This is where you're probably going to want to have your technology. Okay. Let's move on to number, whoops, we don't need to see those just yet. Number 18. 18. My square root is by itself, right? Okay. So I'm going to go ahead straight and square both sides. Okay. Square both sides. All right, we're going to do this one by hand, and we're going to do the next one by hand. Actually, I'm going to pick 2. Here we go. Y'all ready? What happens if I square 3 and n? That's going to be like 3n times 3n twice. How many n's and how many 3's? 2 3's, which is 9. How many n's? 2, which is n square. Okay? On the other side, the square of a square root cancels, so I get what? 10n minus 1. For the first time in solving these problems, I've come up with a square, which means now I may have 2 possible answers. In the math department, we call these the booger problems because there's sometimes 2 answers work, there's sometimes 1 answer works, there's sometimes neither one of the answers works. So guess which is the easiest way to solve it? Calculator. Let's finish this first one just so we can appreciate how nice our calculator can do it for us. Everybody ready? All right, I'm going to move everything to one side. Okay? And because that's what we do. When we factor, we're going to do factor, and we have to set it equal to 0. So I'm going to bring 10x over here, 10n, and I'm going to bring 1 over here plus 1. This will factor. I'm going to move down here. 9n squared minus 10n plus 1 equals 0. It does factor in 2 sets of parentheses. Okay? It does factor in 2 sets of parentheses. No, I'm just ignore 20 for a second. I just needed more space. Yeah. Just ignore this for a minute. We'll get there. Okay, you ready? All right. I'm going to break 9 in. I think I'm going to try 9 times n times n. This is the one where you have to do inners and outers. There's only one way to multiply. Name 2 terms that would multiply to give me 9n squared. It would have to be either 3n times 3n or 1n times what? 9n. I'm noticing a 10 in the middle. So I'm thinking 9 and 1 might give me 10. So I'm going to try that first. How do you get 1? 1 times 1. Okay. Now, the last term is positive, so I'm going to add to get 10. Actually, I'm going to add to get negative 10. Minus, minus. Okay. And that works. Negative 1, negative 9 gives me negative 10. I factored it. Now I need to split and solve. First one I get's a fraction. 9n minus 1 equals 0. N minus 1 equals 0. Second one's easy. Who knows the second answer just like that? Positive 1. If you move this n over, you have to add 1 to both sides. Okay? This one, though, not quite as easy. How do I solve to get n? I'm going to add 1. 9 times n is equal to 1. Now, how do I get rid of the 9? Divide it. So I'm going to end up with a fraction of 1/9. So my 2 answers are 1/9 and what? 1. Here's the messy part. You would technically have to do what? Take 1/9 back in here and see if it works in 2 places, and also go back and put what? 1 in there. Or we can say, you know what? My calculator can probably do this for me. Okay, we have 2 resources. We have a calculator. We have a Chromebook. Which one do you want to check first? Because I want to try both. Huh? Calculator. Okay, let's go to calculators. Grab your calculator. Everybody has been using a calculator. Okay. I think the Chromebook's easier, but we're going to try the calculator. Okay, clear. First thing we're going to do is we're going to do intersection. So we're going to practice. Can I erase this? Everybody got copied all the answers? We know the two answers, right? Okay, so Miss Jessup's going to erase this. Okay, here's what I want us to do. Everything on the original problem on the left, I'm going to put it in Y1. Everything that's over here, I'm going to put into Y2. So I need you to do that. Let's do that on our calculators. Hit the Y equals button at the top. I'm not sure if yours does it, so use mine for now, okay? After we do this one. All right, so 3n, which we have to type in as 3x. Does everybody remember the shortcut key for x is right here next to the alpha? You'll just automatically put an x on there real quick. Okay, got to do a big square root. Your guys has the bar. I have to use parentheses. 10x minus 1, and I have to tell it that's all I need to take square root. Everybody got them in there? Okay, just in case your screen is crazy, let's do zoom 6. Zoom key 6. Zoom 6 takes you to a standard window, which is like a regular little square of graph paper. Ooh, do these two equations touch each other? Yes. Now, here's the thing. Do you don't remember how to zoom in? Okay, calculator. Hit the zoom key. Do you see, can you tell that there's two places right here where it touches? Okay. Have you got this on your screen? All right, I'm going to talk about the intersection point. Do y'all see that it does cross right here at the center? Okay. So here I go. I'm going to hit zoom, and I'm going to zoom in, number 2. And there's a little teeny tiny flashing cursor right in the center. If you want to move it up and over, you can. Otherwise, press enter, and it will redraw right around the center. I do see a better image now. It does definitely look like it touches 2 times. So I'm going to hit trace, and I'm close to the lower intersection point. Here's the steps. Second, calc. Number 5 is the intersection. Press enter, enter, enter. And 0.111111 is the same thing as 1/9. So if we go back off to the home screen and we try 1/9, we got 0.111111. Now, I go back to my graph. If you haven't done it, let's do the second one. We have confirmed that it does cross 2 times. So I'm going to now trace, and I'm going to go up till I get closer to the other side. It doesn't like it when I go too fast. So on my screen, I have to go kind of slow. Now I'm closer to the upper one. You have to trace close to the upper one. Did y'all see that? Now, second, calc, number 5, and again, enter, enter, enter. And it will find the closest intersection. So what is my second intersection? 1. Okay? So as a result, this is what I saw. This is a straight line that goes right through there. This actually is to the right one and comes up and goes over, and it actually crosses here and crosses here, and that's x equals 1/9. And this one up here is x equals 1. I'm really only interested in the x coordinate. So, I have not tried this on Desmos. Let's give it a shot. Have y'all done Desmos? Same thing. We're going to do the same thing. I'm going to go add expression. I'm going to type in y equals 3, and you can type in n. Okay, I'm going to do 3x. And I'm going to type in y equals, and it has to be square root, and I think it was it 3n?
No,
10n minus 1. Do you see a better picture? And here, Miss Danielle, is where it might be easier. I don't have to worry about tracing anything. Guess what? 0.111 is my x. I'm only interested in the x. And my second one's where? 1. Billy, did you try this one with your Chromebook? Okay, we're going to jump to 21, only because these are taking a little bit of time. First thing I do is I got my square root by itself, so I'm going to square both sides. Again, Miss Jessup learned to do these by paper pencil. When I was a student, I did not have a Desmos. I did not have a graphing calculator at the time. So this is what you have to do if you do it by hand. X plus 3 is now squared. That means x plus 3 is multiplied by another x plus 3 how many times? 2 times. Do y'all remember how to lobster claw these? So x times x squared, x times 3, 3x. What's 3 times x again? So what's 3x and 3x? If you add, you get 6x. And then 3 times 3 is plus 9. Don't put your calculator away. Don't put it away. We're going to still need it. This over here, okay, this over here, they square 4x plus 17. So what I need to do is I need to get everything set equal to 0. What do I move it? Where do I move it? 4x goes over here, and I want to subtract 4x. 17 is going to go over here. I'm going to subtract 17, and I'm subtracting x's from x's and numbers from numbers. So on here I have what? 0. I'm going to end up with x squared plus 2x minus, I think, 8. That factors. So I'm going to actually get two perfect nice numbers this time. X and x. What multiplies to give negative 8 is going to subtract to be 2. 4 times 2. The bigger number wins the sign. So 4 would be positive and 2 would be negative. Don't forget to split and solve. This time the answers are much, much easier. What are my two answers? X equals negative 4 and x equals what? Now, here's the question. Do they both work? If I did this the right way, I would take and I would put negative 4 in here for x and here for x and check it. Then I'd come back and I'd put positive 2 in here for x and positive 2 in here for x and I'd check it. I'll give you a hint. One of these does not work. One does. How are we going to be able to determine which one works and which one doesn't? I would use my calculator from the start. So guess what we're going to do with our calculators? There we go. We're going to put this in where? Let's put this in y1 or y equals. And we're going to put this one where? I know you guys are tired and I know you might not enjoy this, but I'm trying really to show you the easiest way I think you can do it. I'm not going to use the calculator. I'm going to use Desmos. Okay? Was it x plus 3? So I'll change this one to x plus 3. So x plus 3. What was the other one? Huh? Does it work? 2 works? What's my equation? 4x plus 17. 4x plus 17 square root of. Okay, which one works, guys? Only 2. Do you see what happens? So even though we got 2 possible answers, only one of them works. Now, having gone through the paper pencil method of factoring and moving things over and getting 2 possible answers, what do you think is the easiest way to solve what we call the booger problems? I think Desmos is by far the easiest. Now, I will conclude this by saying that last year, before we had Desmos, we did use the graphing calculator, and this was the picture I got. So, do I see the same thing that we just saw on Desmos? Yeah. So you probably could have said, you know what, I do think 2 works, because on the picture, 1, 2, so I have x equals 2. That's the only solution that works. So you'd basically cross that out and say, you know what, negative 4 does not work. Positive 2 is the only solution to this problem. So my suggestion, these are called the booger problems for a reason. Do you see why they're kind of called the booger problems? That's true. Nobody loves doing these problems. But I'm trying to say, I really think Desmos is by far the easiest way to approach these problems. You're looking for an intersection on Desmos. I'm going to write that down. Look for intersection on Desmos. Look for intersection on Desmos. All right, we're going to wrap up the notes at this time. There are a few that we are not going to get to. I have recorded the answers for the rest of the notes. So if you'd like to finish to confirm that you are on the right track, this would be the answers to the last few problems on this set of notes. The challenge problem in 25 is a cube root. So if you ask yourself, how would I get rid of a cube root? See if it comes to you. 24 is no solution because you're going to equal a negative. And then 26 is actually asking you to work some word problems. So those are the answers. And we'll wrap up this notes.